Welcome to Natural Habitat Adventures Daily Dose of Nature. Today's topic, Life in the Great Australian Desert, Biomes of Australia, Part 4, presented by NatHab Expedition Leader Nikki Sentinella. I'm your host, Rob Mess. Thank you so much for being here with us today. Over to you, Nikki.
Hi everyone. Welcome to part four of this little series I've been running. Um, and we're going to be looking at the Great Australian Desert, which, having just done a few of our southern itineraries, I think is an image that many hold of Australia. So I wanted to take a little bit of a deeper dive into what it means to have desert as our primary biome, really, and what that actually because it isn't just a vast wasteland of nothing. You'd be surprised at how much there is there. So I'm really excited to dive into that today. I'm presenting here from Awabakal country, which is just north of Sydney. And it's really nice to be back on home turf presenting these. I am Australian. I grew up in Sydney. I am an expedition leader here in Australia and also up in Canada, sometimes going to my polar habitat. A naturalist and I am a conservation biologist, and I'll talk a little bit about some of the work that I did in the desert as well. So I worked in a couple of the deserts bordering the dingo fence, which I'll mention, and I take a fair few photos. So you'll see some of those photos from me, some from one of my co-researchers, Matt, and then anything else is credited as well. You may hear some cockatoos in the background as well. That's just this time in the morning. It's about 5 a.m. where I am, but it means our sulfur crested cockatoos are waking up. So if you hear that, that's what that is. So what am I going to talk about today? I'm going to look into what is the Australian Outback, what is the Great Australian Desert, where is it, who lives there, and I'm going to dive into the diversity of the desert. So I'm going to talk more about our animal species, more mammalian focus on this one, but I'm going to explore some of the adaptations that our species have to our desert biomes and how they make it such a productive and fruitful area. And then at the end, like Rob mentioned, there will be some time for questions. So if you have any questions, please shoot them over and I will do my utmost to answer them. So I think when most people think of the outback or the Australian desert, we think of Uluru. This is our beautiful red rock in the center. It is pretty true to center. I'll show you on a map in a moment. Uluru is a really beautiful and culturally significant site, and it's something that I think would deserve a whole webinar in and of itself. But this is just a really small center of what is the majority of desert or semi-arid landscape that extends all across Australia. So I'm going to broaden your view a little bit. I'm going to move a little bit away from Uluru today. We'll come back to it hopefully at another time because it is just a beautiful, beautiful place to visit. But the Great Australian Desert in general is actually 10 deserts, not just one. And it covers a lot of area. We're looking at over 1 million square miles of true desert. When I say true desert, there are some criteria, as I've mentioned with other biomes, that are defined by temperature or rainfall or the species present. And in most descriptions, true desert covers about 18% of Australia as a landmass. If we extend that though to our semi-arid climates as well, so things that meet similar criteria, but not quite in the true desert sense, functionally they function as a semi-arid or an arid environment. We're looking at about 35% of Australia's landmass. About 40%-ish is covered in sand dunes. So there's sand dunes all across our desert and arid climates, as well as our coastal communities as well. So we have a lot of dunes around. Um, and it is just a beautiful, rich environment that changes across this space. Our desert in general, and I'll refer to more in a broad sense, and I will take examples from all over this Great Australian Desert, this multiple desert area. But it has some of the world's oldest rivers. The Lara Pinta, or the Finke River, has been running the same course for several hundreds of thousands of years. And depending on what evidence you look at, it could be the oldest river, but that is a deep dive. When we think about the ages of rivers, especially as something that moves, well, they can be quite hard to age. Things like fish fossils are a pretty definitive measure of age. But when we start looking at the geology, we have to ask, was there always water flowing? How does that system work? And then the question blows out a little bit more. The geology we know does extend to about 3.8 billion years, so very, very, very ancient. Australia in general is a really stable landmass that has been in the one area for a long time. It's shifted as a unit around, and we've seen that climate change as we've shifted pretty much up from Antarctica and started moving north, and that actually created this desert environment as we move further north, as well as these polar winds that are helping to reduce rainfall in the center. And it's very flat. Spoken about it with our grass plain series. Australia is the flattest continent on Earth, and in that way, we don't have these mountain ranges to catch all this rainfall. And so we see these massive rain shadows that form across the crust of Australia, really. We see three cratons, which are basically really stable shields of rock. I think of like the Canadian shield as the shield that we talk about, but we have three true shields, which is actually uh, the crust of Earth and then also the upper mantle. So we have really stable area of crust that doesn't have faults going through. We have three of those that came together and have maintained that arrangement, and that gives us our age of about 3.8 billion years, give or take. um, it's also home to the largest terrestrial mammal, and I think that just speaks testament to uh, the underappreciated diversity of our deserts. There is enough there to sustain our largest animal. Grasses are its main diet, and I'll see if you can guess our largest terrestrial mammal. Spoiler, it was in the bio, but we'll come to it in a moment. And I'm going to talk about some of the adaptations as well. So, this Great Australian Desert, this is what it looks like. We see these maps of Australia, this big red centre. Uluru is pretty much right in the centre, is on my next map, but you can see how much of this area is red, really. And we see these really iron-rich soils that lend itself to that red colour. And you can see just around the edges, we have our bits of green. And it's here that we see most of our productivity. This is where most of our humans live. And a lot of our farming, agriculture, primary production are here in this place. If you look at Australia at night, you'll see a ring of lights around the outside because in the center, it's not as suitable for humans. But we have plenty of species that have figured it out. And so you can see 9 of the deserts listed here. There's a small one in the center not listed, but that shows you all the deserts that make up the Great Australian Desert, primarily sort of center and then across to the west. And we see there's a mountain range on the east coast that helps to deliver a bit more rain into the east center. And you can see here on this map, this has our state borders, but also a bit of a clearer definition of our deserts. You can see Uluru is listed in the center there, just southwest of Alice Springs. And I'll show you some photos from Alice Springs as well when I was there. You can see this big green patch in the center where the Simpson and the Strzelecki Desert is. And you may be thinking, why is there a green patch when we look at the satellite? And it looks mainly red, but you can see there's almost this white patch in that area near the Strzelecki and Sturt Desert. And that's because that's where we have Lake Eyre. And Lake Eyre is a lake that doesn't always fill up, but when it does fill up, it's Australia's largest lake. and it is very, very not even seasonal, it's like multi-year dependent on having these massive rain events. Then this massive inland sea fills up, it no longer connects to the ocean, which is why when it drains, there's a lot of salt deposited. And when you look at the satellite image, that's that white that you can see in the corner near the Strzelecki Desert there. That's so as all that nutrients pulls down and then evaporates, we have this high salt concentration. When lake air fills up, it is the same salinity as the ocean when it's at its fullest extent. And then as it evaporates, it gets more and more and more salty as it goes down. So you can see Lake Air in the bottom here. I love the borders of Lake Air because it'll never stay the same. Uh, and you can see how many rivers contribute through. And this is, if you look at the map in the bottom corner, you can see how large that catchment area is for Lake Air. And it's massive. It's, you know, about a quarter of Australia is filtering into this lake that doesn't always fill up. It becomes this amazing hotspot of biodiversity, a huge bird breeding area. You'll have pelicans that have never been here before somehow know that Lake Eyre is filling up and go and head all the way inland to go and explore this wetland. It in itself deserves a whole other, hour to talk about. But I just wanted to explain why we see that sort of green white area in the center of our desert map. So there are deviations to this. There is, of course, water, but primarily we're looking at a drier climate. And so the rainfall here, this is more typical of the rivers that we'll see. This is when I was flying from Adelaide up to Alice Springs and went over some of these small little rivers. And you can see the texture of the sand dunes there on the left. And that's very typical. We mainly have our longitudinal sand dunes across the desert. And they're meant to be there. They're really important that they move and they shift. But we do see a fair bit of rainfall. If you look at deserts around the world, we actually have a high rainfall for a desert environment. So we're looking at 3 to 10 inches annually, with an average around 9.84 inches across like metered stations. And so that's quite a high rainfall. But what we also see is a huge evaporation rate. We don't have places that hold the water. All of that water evaporates quite readily, and so plants and animals as well need to make sure that they're getting as much water as they can quickly when that rain does fall. And so a lot of adaptations are going to be focusing on capturing, storing, and maintaining the water that they have until that next rain event. We also see thunderstorms. So we will see sort of a lot of that rainfall in the front and then nothing. And that also changes the dynamic as opposed to having a more consistent rainfall. We also see from those thunderstorms, we do get dry lightning. And I mentioned we're seeing a lot of red from our iron oxides that are making this rusty red color that's so iconic for Australia. But it means that we do also get dry lightning strikes. And so we do also see grass fires in this desert environment, which is uh, not always an image that people hold. You're having already this dry, desolate area, but then you have enough fuel to make a fire. And those grass fires can spread a fair way. So where there is water, it's really important to hold on to it. This is a beautiful little eucalypt gum tree who is just holding on. I just love this tree growing out of the side of this gorge right next to a waterhole. This one's found a way. And if you have a look just above it, you can see a little line of vegetation that's following the natural crevice. And you'll see this all throughout desert environments. You know where water does accumulate or does fall even if it's currently dry. And that's because our vegetation is going to go straight there. So this is the kind of coming into the edge of the semi-arid region. This is just outside of Alice Springs in the West MacDonnell Ranges in the Larapinta Trail. So this is a 220-kilometer trail that goes from Mount Sonder back into Alice Springs. And I did this hike 3 years ago now. And So some of the photos will be from that, and you can see this beautiful landscape. This is a small mountain range. This is mountains for us. You can see they're quite smoothed out and flattened. They're not that high, and that's because they were created such a long time ago. They've continually been weathered. All the sedimentary layers have come off, and a lot of this has come from, you can see in the back mountain range, this sort of tilting, folding action where the landmass is tilted up, but it's not the classic massive folding, breaking mountains that we would see that would form the Alps or the Himalaya. And so we have this more gentle mountain range. It does catch water and it can be really, really beautiful here. When I did this, you'll see some wildflowers come out. We had some really, really nice April rains, some spring rains, um, and sorry, some fall rains. I'm upside down. And it did mean that a lot of our wildflowers came out. So I'll show you some of them. Uh, it does collect water, so these are some of the gorges. Uh, we would often say how gorgeous it was. Yes, I know, annoying, but you can't not use puns when you're out here, especially when you've been walking for 10 days. So these are some of the gorges, and they do catch a fair bit of water, and then they hold that water because they have that rocky base. And these become really important kind of oasis for a lot of animals to come and drink from this water, as well as the heightened vegetation around here. You can see the one on the right, it does get a little green. We will see algal blooms that'll come through, especially when we have water sources that are no longer connected. We'll start to see some things develop in those water sources. So even when the water is running low, animals then have to consider, is that water safe as well? So looking at some of the biodiversity, and these are all from that trip. So you can see some really beautiful flowers. In the center, there's the purple and white flowers. This is the mulla, and the mulla is absolutely beautiful. It just formed these fields, but they're really all quite uh, rough. They're all quite leathery. They're not these beautiful, rich, wet, moist flowers that we see everywhere else. They often kind of have that papery, like our paper daisy or our everlasting daisy would go would thrive in a semi-arid environment. And these are all adaptations from our plants to reduce that water loss. Their leaves will be much smaller, or they will hang vertically to try and avoid evaporation from the sun. They don't want to lose any of their water. And so they will be shifting as much as they can, but they form this basis and this starting point for a lot of our biodiversity here. There is less biodiversity in arid, semi-arid environments, purely because of the lack of resources. So we see fewer species in this environment compared to our coastal regions, and especially compared to our tropic regions up in the north. But there's still a huge diversity that we shouldn't underestimate. There's some beautiful butterflies, again, because it had rained, they'll come out. And here on the right, this is a termite nest. And if anyone's seen some of our other termite nests in Australia and around the world, they're much larger domed structures. Um, in the desert here, because it's so hot, termites actually limit the amount of surface area above ground. They focus more on having their area underground. That area underground will be a more consistent temperature, will be quite cool, and then they can have this more vertical structure to help pull heat out, but also make sure it's not capturing too much heat from the sun. So you see these little spires sticking out. It's pretty incredible. And these are from our termites. And so of all of the insects and all of the larger animals, our mammals and reptiles, the largest diversity by far is from our ants and our termites. There are a huge diversity of ant and termite species, and they're really important. So underneath this sandy soil or this rocky soil, you'll have so much activity, and they act as a really important food base as well for a lot of our other species. We do have reptiles. We even have soft little geckos as well. But we don't just go from small little lizards. We also have our fill-neck lizards, our shingleback, and also our sand goannas, which are considerably larger. And that's just showing there's enough food around to support some of our larger species. Our largest monitor lizard is our parenti, which can be over 2 meters, over 6 feet long. It's pretty impressive. And then this is Matt here in the background, and he's handling this for a biodiversity study we were doing in the Sturt and Strzelecki Desert. So he was looking at species, measuring length, weight, seeing how healthy and what diversity of species we have here in this desert region. We can see it's pretty bare otherwise behind. But did you know we also have a fair few frogs? We have quite a number of frogs. This is a specific species, the painted burrowing frog. But of the genus, the Neobactricus, you can see in the map at the bottom there the range of this genus. And so these are called burrowing frogs because, oh my God, they burrow. Yes. So they are able to burrow when they're adults and hide in that cooler substrate of soil, but they're also able to dry out the top of their skin and retain all of the moisture in their glands, and that allows their body to continue to move. And they really just reduce all of their metabolism, their heart rate, and just remain buried for years at a time, depending on the species. But we are looking at years and years of their adult life is spent underground. As soon as that rain falls, it is a massive transformation. And this is true of many of our species. You'll see as we go through. We will only need a few days of good rain, and these guys will start to come out, so much so that they can feel and hear the rain pattering, and that's a cue for them. Even before the water reaches the frog, they can feel that vibration that is telling them that there's rain falling on the surface. When they do lay their eggs, they lay, this species 600, but other species in the genus lay up to 1,000 eggs at once. So they really, all eggs in one basket, or all eggs in one rain event, so to speak. They only take 3 days to hatch. So it is a very rapid process of like, there is water, we're going to pass on to our offspring. And so very quickly we'll reproduce. We have these massive boom events, we call. So we have our bust during our drought and our boom during a rain event. This would then obviously become an important food source for some of our lizards that we saw before. And so when they're adults, it's really important that they stay hidden. So we can see this camouflage would be really perfect in a sandy desert environment. So when they're on the surface, they can blend in a little bit better so they can go out and do what they need to do, eat as much as they can. All the insects will be coming up. Um, it's just, it's bursting with life. It's quite incredible to see. And people come during rain events to watch certain species of burrowing frog emerge because it is such an amazing event. Um, Starting from some of our smaller mammals, I'm only going to list a few because there's so many here. These guys are adorable. These are our dusky hopping mice pictured, but there are about 10 species of hopping mice here. Contrary to a lot of the marsupial diversity we have in Australia, we do have some placental mammals. So placental mammals are our rodents and our bats. That's it for native placentals. And I'll talk about the dingo later, which is also a placental. Um, but otherwise, a lot of our species are marsupials. And I'll talk about marsupial adaptations in a moment when I get to that largest mammal, which you're trying to guess what it is. And these guys are native rodents. They do hop like kangaroos or like wallabies. They have these beautiful, massive ears, and this actually helps to distribute heat. When it's really hot, they can let that heat out. And similarly to our burrowing frogs, they have a really high breeding potential when the rains come. So they don't breed seasonally. They will breed whenever things are good, which is quite common for our desert environments. And then they will have a large breeding litter, and so that they can spread as much as possible. We'll see the population expand quite quickly. And then when it's a drought season, and drought season can be several years, the population will reduce. Some won't make it, some will be eaten off because it's a really important food source for our larger predators. Predators for these guys would be like our sand goanna or our monitor lizard. You would see a number of snakes, birds of prey, our wedge-tailed eagle, which is our largest eagle. Won't prey on these guys. They could if they were hungry, yeah. But they'll try and go for larger prey first before trying to pick off all of these guys. And so that population will reduce, but is able to maintain a slow, stable population in quite small numbers. This is often done in places called refuges. So there'll be small areas of habitat where the conditions are a little bit better. Maybe it's near a waterhole, maybe it's just in a little bit of a shadow. And so evaporation is slower. And then as that rain comes in, they'll start to spread their home range and their habitat, and they'll spread outwards with the rains. So this is what their typical habitat would look like. This is over in the Strzelecki Desert. You can see our access road just faintly in the background there. We're driving over sand dunes. And these are some of their footprints in the sand, which are adorable. They look like little jelly bean toes who make out all their toes. Sand is just such an amazing place for tracking because you can see everything that was there. And if you clear a plot for one day, you can see everything that was there in the last 24 hours. So, a very useful tool for us when we're out there. This is Josh releasing a hopping mice. Again, we are checking for biodiversity, so they're often in a little bag, and then we weigh that bag, and then he's just released it from that bag, and it's hopping. All right, who got it? It's the red kangaroo. This is a big boy. This is our largest terrestrial mammal in Australia. Obviously, our sea creatures get a little bit bigger, but this is the largest we've got. Now, they can stand much taller than you or I when they stand up, especially our big males. I think tallest is like around 8 feet or something when they're really standing up proud. They are an impressive creature. And the red kangaroo has many adaptations that help it. You can see the range here in the bottom corner. And you can also see they're not always fully red, depending on their environment. They may be more red, they may be more kind of grey, and that will be dependent on where they are to help them blend in, but also to help them reflect some of that heat as well. It's often paler underneath, where their fur is thinner, so with thinner fur, more UV can get in, but if it's a light color, then it will reflect out. These guys will be hiding in the shade during the day. If they can find caves and rocks and things like that, great, but usually it's in the shade of small shrubs and maybe our mulga tree. Our mulga tree is an acacia species that is in behind this picture here of our red kangaroo. They will be sleeping during the day, that classic lounging kangaroo look, and then they will be active dawn and dusk and throughout the night as well. In the really hot environments, they'll be out pretty late in the night. They are really efficient at maintaining all of their energy, and this is what allows them to survive in an area that may not look like it has as much food. Being a marsupial is going to be an advantage in general. In the way that you reproduce, you are using less energy than developing young in utero, in your placenta. You can birth them while they're underdeveloped, have them go into your pouch, and then suckle on milk. And that's less energy taxing and it's less water taxing, really, because a lot of that energy comes from the movement of fluids around our body. And so by being a marsupial already, it means that they're able to cope with lower food availability. Some kookaburras calling in the background now. They also have another technique called embryonic diapause. Embryonic diapause is where they're able to start to develop an embryo. So they can mate with a male who may be around at this time, but it doesn't mean that you're going to stay around because you've got to keep moving for food. So you can't stay there. So it's really helpful if you can mate with a male, but you don't want to raise your kids yet because the conditions are not good. So you're going to put that embryo on pause. You can put that on pause for nearly a year until the conditions are better or you find a better spot. And then you go, yeah, okay, let's go. Now I don't need to be near a male because I've already prepared one earlier. So um, they're able to hold on to that for up to a year, which is really incredible. And then once they have their offspring, they can straight away have another kid. So they could have an embryo on pause, they could have a joey in the pouch, and they can have a joey at foot all at the same time. So they can sustain 3 generations when the conditions are good straight away. The milk that they produce from either teat will be different depending on the needs of that offspring. So if the joey's in the pouch, it needs to develop, it will have a more fat-rich milk. And then the joey who's at foot, who can eat some grass, will get a fat, poorer milk. So all of these things, mum is just trying to conserve as much energy as possible, which is really incredible. They're just so well adapted to this home range. And you can see how far that range extends. They can travel pretty quickly and pretty far, and they're very efficient in doing so. The Achilles tendon in their feet that gives them that beautiful hopping, bounding that we see from our kangaroos is relaxed when it's in the air. So when they go down onto the ground, it coils up like a spring, and using gravity and the weight of their own body, it recharges that spring so that when they go to jump, it releases. And so you're most at rest when you're in the air, which is incredible. They can get into a bounding rhythm in which that bounding, that bouncing that they're going through, it's not only just recharging and releasing these springs, it's also helping to pump their lungs and pump their heart. And so their whole internal organ system is in rhythm with this jumping. And so that makes it really, really efficient, far more efficient than any of your endurance horses anywhere in the world. These guys are very, very effective at covering large ranges. The males, the big males that we saw before, they have been known to record a single leap of 8 to 9 meters, which is, I have to look it up, 29 to 30 feet. So imagine just clearing 30 feet in one go. It's incredible. And up to 3 meters high. They generally don't want to jump that high, but they can because that takes a lot of energy. So they have to really be pushed to jump that high. So that's about 10 feet in the air. Pretty impressive. It just shows us how much diversity there is in the desert to sustain our biggest animal. You would often think like, oh, if there's a lot of food availability, that's going to be near the coast. But these guys have made it work, and I find it so impressive. The other thing that we have that you may not know about is our camel. That's not our camel. We actually have the largest population of wild acting dromedary camels in the world. I say wild acting because they are a domestic breed. They were brought over there was a few in the 1840s, but then the main introduction was in 1860. And they were brought over for pack animals, to be used as pack animals in order to traverse our great deserts. So when Europeans came over here, they wanted to get from A to B. They wanted to build the first telegraph wire, as well as any communities along the way, and they did that using camels. The camels came from a few places around the world, but a lot of them were Afghan camels, and they were brought over with Afghan cameleers, who would then provide transport for anyone who wanted it. And so over a period of about 50 years, 10 to 12,000 were introduced. And then as soon as we started getting more infrastructure, we started having roads and motor cars, and then later we train line as well. These guys were just let loose. They were like, sweet, we don't need you anymore, off you go. They were like, this is the best deal ever. There's a whole desert and there's no other camels to compete with. The biggest thing is a kangaroo who eats grass. So do I. I can eat it a little bit quicker sometimes, and I can store water for a long time as well. So they were very well adapted to the desert condition, and it meant that their population exploded. So in 2005, we estimated there were about 500,000 camels, and they do pose a problem for us because they are not native here. They have hard hooves, which none of our native animals have. So they're compacting the soil. And while they can survive without water for a long time, they also have a great capacity to consume water. So when there's lots of water, when the rain comes, when that water hole fills up, the camels will drink a lot of it very quickly. And it means that water is no longer available for the other species that need it. So, um, yeah, they are causing a bit of strife out there. We do export our camels back to where they came from as well, and is a way to, if you want a camel, come take a camel. We don't need them. So they are posing a bit of a threat to our native species. So not not a native animal, a bit taller than a kangaroo, um, but they are around in droves. The other placental mammal I wanted to touch on is our dingo. A dingo is considered a naturalized species, so they've been here for about 5,000 years, and they fulfill this apex predator role that was once held by probably our Tasmanian tiger and our wolves, which are no longer found up in this region. And this was a number of factors of climate getting warmer as we shifted north, the introduction of the dingo from New Guinea area maybe outcompeted some of our calls, and so we started to see a shift. But over the past about 5,000 years, they play a really important role as being our apex predator in this desert environment. Unfortunately, they've been a threat to our sheep and cattle industry, mainly our sheep, and so we constructed a fence. We constructed a nearly 6,000 kilometre fence to separate dingoes from not dingoes, from cattle country from sheep country, to try and reduce that loss. And this is the study that I was involved on, and I'm happy to go into that in more detail later as well. But we were looking at the effects of biodiversity on either side of the dingo fence. So where we have apex predators and where we don't. And as you can imagine, as we've seen around the world, who would have thought apex predators are really important? And so we see a complete change in the quality of our grasses and shrubs. Our sand dunes don't move the way that they should when there's no dingoes. So it's really important that we maintain the balance that we now have with our dingoes and our apex predators. I recommend looking this one up, it's a good one. So I hope that shows you a little bit more about what the Australian desert is like beyond just Uluru and the Red Centre. It is a really large reaching area that has a huge amount of biodiversity. You can see a whole number of different species. The way that the water pulls in will then support vegetation, which will then support a whole host of species. And when those rains come out, everything is going. And so we shift our focus a little bit more onto this longer term approach rather than thinking of annual seasons. We want to think about years. I think that's really important to think about when we think about conservation as well, and protecting these amazing environments is we need to think on a longer scale because time just works different in the desert and we need to respect that. And you can see just some of the beauty of this environment. It's not just dry sand dunes, even though they have their own beauty as well. There's a lot to see and a lot to marvel at in these landscapes. And if you want the best sunset, I reckon it's a desert sunset. Definitely the way to go. So thank you so much for listening and exploring Australian deserts with us. It's just such a little sample of what the deserts hold here. And I hope it spurs you to have a little look at some of the dry environments around you. Feel free to read up on it. And if you have any questions, I am more than happy to answer. And this is a nice aerial shot of our sand dunes. You can see these perfect longitudinal dunes, which I just think are beautiful. So thank you so much for listening, and let us know for any questions.
All right, thank you, Nikki. Now, before we start in with the question and answer session, I would like to remind everyone that you can submit your questions via the question field in your control panel. All right, let's get to some of these questions. So, can you tell us how these gorges eroded over the years? Is it mostly due to rainfall or is it wind? Can you
Yeah,
shed some light?
totally. So yeah, Bit of everything. Um, the gorges that we see are these beautiful kind of chasms that come through these rock formations, and they're on the edge of our lower mountain ranges. The main actions we're seeing are some uplifts, some tilting, and that will create an exposed front on one side. As that sediment wears away, it's now vulnerable. Water will be one of the ones that will carve through, and this is going to just take a really long time. And so we're seeing these dramatic formations that are occurring because of the time scale that we're looking at. Easily, some of these rocks have been exposed for 1 million years, maybe more, um, slowly wearing away the sediment. And then we've had glaciation events, we've had big rainfall events that have deposited more sediment. And over time, we get stress fractures. But really, in the past, I would say in this region, at least 200 million years. I'd have to check depending on which area we're looking at. We've seen a lot of exposed weathering, and so nothing's changed. We haven't seen any new Earth being formed. We haven't had this volcanic activity. And so it just means that things can just weather and weather and weather and weather. And so we see a lot of the cracks and a lot of the rainwater events that will split this rift and then continue. Wind will often be a smoothing effect. So when we see it a bit more jagged, I'm thinking more. So just time, a lot of time. Yeah.
All right, thank you so much for addressing that. So let's talk about the burrowing frog. Now, do they have a natural predator that keeps them under control since they too lay quite a large number of eggs?
Yeah, they're not at risk of taking over. They lay a lot of eggs because majority don't make it, and they become a food source to everything. You can imagine, picture like a dry desert. There's a few little valleys and nooks and crevices. There's a waterhole. That waterhole's dry. Then it fills up. These frogs come out and lay all of these eggs, and now you have all of these tadpoles. Everything that's hungry that has also just come out of that rain is going to go investigate that pond. They're going to get water from that. They're going to eat those tadpoles. So any of our birds, a whole host of lizards, uh, anything else that's just bigger is going to come and have a go at them. So there are a lot of predators, and in that period of a rain, everything's really productive, but also everything is really competitive because it is a finite resource there. It's going to evaporate quickly. So everyone's jumping on everyone. So these guys are by no means overpopulated. And we are seeing, especially where we are using water, um, as well as where we have a lot of camels using up our water, we are seeing those populations are under threat because of that habitat degradation that's happening. So, not overpopulated. We want all of our burrowing frogs.
All right, thank you. So, how many marsupial species are found in the deserts?
Hmm. I know mammal species, it's like 140 odd species of everything. Um, 103 species of mammals um, that are across the desert region. That does include our rodents as well, so our little um, hopping mice, as well as some of our other native rodent species. Um, so I don't have an exact number for mammals, but it'll be less than 103.
Okay, thank you so much. Again, I'd like to remind everyone that if you do have a question, go ahead and go to the question field in the control panel and get them on in there. So let's get to the next one. So, are there still invasive rabbits in Australia? And if so, where are they?
Yes, there are invasive rabbits. Where are they? Everywhere. They do come into the desert environments. That's one of the things that we see with dingoes is actually they limit the rabbit population. Rabbits are a little bit bigger than a lot of our small marsupials and our small rodents, and so they're a much more enticing prey species for our dingoes. And where we have dingoes on that side of the fence, we don't have that many rabbits. And where we don't have dingoes, we have an overpopulation of rabbits. They eat a lot of our grasses down. They outcompete our smaller marsupials and rodents. Um, The rabbits are everywhere. They were introduced to Victoria in 1836 by a bloke called Thomas Austin and his cousin or his nephew, William. He went over to get some rabbits to make his home feel more like the English home he was familiar with, in addition to a spot of hunting. And so it was a comfort thing. They brought over 12 pairs, but William couldn't find all of the domestic bunnies he was meant to find, and he found some wild ones. And it was that mix of wild and domestic genes that meant that they were absolutely happy. And over 50 years, they covered all of Australia. And so we have about 100 million rabbits. It changes quite a lot depending on resources, but we have millions and millions of rabbits everywhere. And it is definitely a problem that we're seeing. So, more advocacy for our apex predators because it seems to be helping with our rabbit population.
All right, thanks for addressing that. It's a lot of rabbits. Um, so are desert wildfires a big problem, and do they ever affect the human communities?
Yeah, for sure. Yeah, so we do have a number of human communities. We also have a large Indigenous First Nation population throughout Central Australia. The fires that we see are mainly grass fires, um, and they do have the capacity to spread pretty fast. Once they get enough heat, they can sort of go along the runners of the grasses, and if there's a wind, it'll just clear a whole area. Some areas the fire is important. We do have species that need fire to germinate, so that fire will help to crack open seed pods and things like that. But when we look at the mulga communities, which is our acacia species, which is one of our main trees down in the areas I was working in certain Strzelecki Desert, this mulga wood is actually not resistant to fire. And so fire is a concern for these areas. Um, some of you may have heard of cultural burning. So in some areas where the grasses need fire, First Nations people will use fire to help spread seeds. They can use the fire to help hunt our goanna or our uh, heath monitor, and that will be in smaller patchwork areas. That mean that it's going to rejuvenate the land for the next few generations, and they won't come to that area. But in areas where there's mulga, they know that you don't burn there because we don't want that area to burn. So we do see fires as part of the natural landscape with especially our lightning strikes on our iron. Um, and we do need to make sure that we are aware of where those areas are and make sure there's enough resilience in the population. We need to maintain enough habitat so that if a bit of it burns, it can still recover. And we're seeing that is shifting, especially as we start to move further into those arid environments, whether we're working there for often it's agriculture, cattle farming, and things like that. There is definitely a risk there. And so we need to make sure that we're thinking about which environments we're in and just being really vigilant with our fire safety as well.
Is there ranching in the deserts, and how does this affect the native habitats and wildlife?
Yes, so there is ranching. There's a fair few, there's a lot of it. We see sheep grazing and cattle grazing. Cattle grazing, cattle ranching is going to be permeating further into the desert environment. And this is what we mainly see on the west side of the dingo fence because cattle can put up with dingoes. It's the concern of smaller sheep that people are worried about loss from dingoes, um, which yeah, it's a whole other discussion. And so we are seeing ranching and it is a concern in Australia because I mentioned with the camels, we haven't had any hooved creatures, any ungulates. And so now we have all of these cattle and all of these sheep and all of these camels and all of these horses, and they have hard feet. And that's compacting the soil and it limits the way the water can penetrate into our soil. When Europeans first came here, they described on how beautiful and fertile and soft and loamy the soil was. And it was when they suddenly brought in all of these cattle and sheep that the soil completely changed, compacted, species couldn't grow, water didn't permeate. Um, So we're seeing some of that arid effect spread because of our compaction. So it is a concern. It's a hot topic, hard to know what's going to happen because it is an industry we are heavily dependent on these days. Um, but yeah, it'd be nice if we switch to like kangaroo, which is everywhere and safe at the moment and doesn't compact our soil. So yeah, big conversations to be had, I think.
So has global warming affected the migration of animals or life in the desert in general?
Yeah, what we're seeing is we're seeing more extremes. So often we think of global warming as getting hotter, which in a desert is there is a limit to how hot you can handle. We already see temperatures up to 50 degrees Celsius, which is like 120 Fahrenheit. We don't really want to be hotter. But what we actually see with global warming is not just that it's hotter, it's that we have more extremes. So it means our droughts are longer and it means our floods are longer. And our species only have so long that they can deal with either one or the other. And what we want is a natural fluctuation. That's what we see here in Australia. We call it boom and bust. We want periods of a lot of rain and we want some drier periods, but we're seeing all of these things get more extreme. And the the results of that mean that our species can't keep the changes that we're seeing are happening faster than our species can adapt. And we have to remember with the word adapt and adaptation that adaptation happens over generations. It doesn't just happen within one generation. And so when we talk about species adaptation, we need to think about longevity and we need to think about that sort of intergenerational care. So yeah, we are seeing a lot of impacts and we are doing what we can to understand those impacts and hope to mitigate that. But it is the global effort for sure.
So when traveling with NatHab, just how much of the desert am I going to get to experience? And of course, am I going to see a kangaroo?
Mhm. Uh, I should hope you're going to see a kangaroo. I don't want to guarantee any wildlife. I have done many tours and I have always seen a kangaroo. So pretty good. In terms of itineraries, we do the Australian North trip, which does go up to Darwin, the Bamaru Plains. You're kind of coming to the edge of that environment. We're coming into a more tropical system. But you do get some glimpses and instances of a more arid environment. In the southern itinerary, we do stick quite far south. We're more in our temperate system, so we don't see this desert environment. But we do see other species of kangaroo. We have our eastern grey kangaroo, western grey kangaroo, and that's probably where you see more iconic Australian animals like our kangaroos and our wombats and our koalas and all that sort of stuff. So definitely not missing out there. But if you want proper desert, then it's the ultimate trip for you. The ultimate Australia trip goes into the Flinders Ranges, Ikura, which is the southern Australian desert region, and it's beautiful mountain ranges. You'll see those gorgeous gorges. You'll see some of those really ancient rock formations, as well as these species that are all throughout this desert environment. We have our yellow-footed rock wallaby, which is adorable, a whole host of amazing parrots, cockatoos, wedge-tailed eagles. Yeah, the ultimate trip, the one you want.
All right. Thank you so much, Nikki. Unfortunately, that is going to be the last question that we do have time for today. So I'd like to throw it back to you for some closing comments.
Thank you, Rob. Thank you all for listening, and thank you so much for your questions. It's really nice to hear the diversity of interests that we have, and I'm really excited that you are as excited about desert as I am. I used to always get desert and dessert mixed up, but I think I like them both as much as each other. And I hope you have enjoyed it, and I will see you next time.
Nikki, thank you so much for taking the time to present for us today. And I'd also like to thank everyone who tuned in today. So if you're interested in information on how you can travel with NatHab, please give us a call at the number on your screen, or you can send us an email at info@nathab.com. Our adventure specialists are happy to help you out. Join us tomorrow for our next daily dose of nature. You can check out this week's lineup, including registration links on our website at nathab.com/webinars. We did record today's presentation, and we will have the replay available on our website soon. With that, I will conclude today's webinar. Goodbye, everybody. We'll see you next time.